Solving orange box. We need oranges to make orange juice. We will be using a big box full of oranges. It is best not to push the box of oranges at an angle. Why? Well, click the video. I don't want to push the box. It uses more force. How about I use physics to help me? Force. Force is pushes or pulls. It is an action exerted on an object which may change its state of motion. To calculate force, we use mass times acceleration, which comes from Newton's second law, so it is measured in newtons. It is also a vector, because acceleration is a vector. Vector is a physical quantity that has both magnitude and direction. Two parts that make up 2D vectors are I hat and J hat. A number followed by I hat indicates that it is along the x-axis or the abscissa. A number followed by J hat indicates that it is along the y-axis or the ordinate. Let's use the FBD to help us see if pushing boxes really uses more force or not. FBD is free body diagram or free baby daddy. We use it in physics to help us visualize the forces that are applied to an object. The force of gravity is applied to an object due to the gravitational force exerted from the center of the Earth. To show this on a FBD, we will draw an arrow pointing down from the center of the object. To calculate force of gravity, we multiply mass times the gravity. Gravity is 9.81 meters per second squared. According to Newton's third law, for every action there is an equal and opposite reaction. For example, the pseudopair. The pseudopair is the weight of an object, or Fg, pushes down on the surface. The reaction is a force that pushes up, which is normal force, or Fn. Sigma F, or Fnet, which is the total force. In our case, we're trying to find Fn. So we'll have Fg plus Fn equals 0 because their reactions are opposite and that they're in the state of equilibrium. Fn will be positive because Fg, or weight, is always positive. Also, Fg, which is negative because negative 9.81 times by your mass is a negative, and then double negative equals a positive. The next force applied is the push force. To calculate the push force, you have to multiply your mass by your acceleration. The push causes the box to move forward. The opposite reaction will try to keep it from moving forward. Thus, friction will be the force trying to keep it from moving. Friction is calculated by multiplying mu k by normal force. All forces that had applied to just pushing forward are used in pushing at an angle. However, the difference would be the fact that the pushing at an angle would have more than one component, and this changes everything. The reason is that when pushing at an angle, the adjacent side of the triangle, which is closer to the theta, is a j-hat component. You have to add gravity and your j-hat component to be able to find normal force. Then friction will be affected because it will be greater since mu k is multiplied by a greater F normal force. Therefore, it will be harder to push at an angle because you have to overcome greater friction. By the way, it required work to move the box. Work equals force times the distance times the cosine. There are forces applied to the box, and the distance will be traveled, and also cosine will be 0 because it is moving in the same direction the forces are applied. And nevertheless, so cosine 0 is 1, so just multiply force times the distance to get work done on the box. And the units for work is joules.